Alright, so number 1, section 12. Keep them straight. Alright. Alright, here you go. Number 1, you're given, you don't have to do the last section. Okay, do that one out. F of x is equal to 4x to the third minus 11x squared plus 10x minus 3. Okay, last time I'm going to explain how to factor and find the zeros for this, and they asked me to find the zeros. Okay, of course you have to factor to find the zeros. If you try to factor this, you won't be able to factor. That means when you can't factor, okay, when the highest power is 2, you can use the quadratic formula. When the highest power is 3 or bigger, you have to go p over q's. So p's are factors of that number, which is plus or minus 1 and plus or minus 3, and q's are factors of that number, leading coefficient, which is plus or minus 1, plus or minus 2, plus or minus 4. Of course, p over q's. Hey, you got the wave today. You're off the hook, Serena. Alright. So p over q's are plus or minus 1, plus or minus 3. I'm just putting q's underneath the q. So when I put 1 underneath all of those, I get that. When I put 2 underneath all of that, I'm going to get plus or minus 1/2 and plus or minus 3 over 2. And then when I put 4 underneath all of those, I'm going to get plus or minus 1/4, and I get plus or minus 3/4. Okay, you have 1, 2, 3, 4, 5, 6 options. If there's any rational zeros, well, actually 12 because you got minus 2. So your guess is as good as mine, since these are all textbook problems. Okay, we'll start with 1. And just cross our fingers, do synthetic division. Coefficients are 4, negative 11, 10, and minus 3. And if I'm right, I should get 0 down there as a remainder. So, synthetic division, add the first column, put it there, multiply by 1, put it there, add, negative 7, and then multiply by 1, negative 7, put it right there, add, you're going to get 3, multiply, you get 3, and then that's 0. It works. So what you have left is x is equal to 1 is one of your zeros. Means it crosses the x-axis at that point. What you have left is 4x squared minus 7x plus 3 is equal to 0. You can factor this or use a quadratic formula or complete the square once you have a quadratic. So this is, I believe, can be factored. Okay, and we're looking for factors of 4. Okay, I can either go 4 and 1 or 2 and 2. So what should I do? 2? Yeah, 2x and 2x. I think that's a good idea. I need to get 7, so in the middle, so I'm going to put 3 here. Okay, and that'll give me 6, and if I put 1 there, okay, I won't get 7. Will I? Nope. That's 6x and 2x. I can't make 7x. So I might have to switch around, okay, and go 4 and 1. Okay, let's try that. And I think that will work. Okay, so I'm going to put 4x. Come on. I'm going to put 4 there. Okay, and I'm going to put 3 over here, and then 1 right there. So when I multiply the 2 inside, I'm going to get 3x. When I multiply the 2 outside, I'm going to get 4x, and I can make a 7 out of that. Okay, only thing is, they both have to be negative. Okay, so give me negative 7 in the middle, and negative 1 times negative 3 is positive 3, so I'm good to go. So when I set this factor equal to 0, I'm going to get x is equal to 3 over 4. And that's my other solution. When I set that equal to 0, I get x is equal to 1. Okay. Do I have to write 1 twice? I don't have to. Okay. And that's it. It's factored using p over q's. Alright, number 2 then. Number 2, section 12. Okay, that is f of x is equal to 10x to the third plus 21x squared minus x minus 6. Okay, again I have 4 terms. I try to cut it in half, see if I can factor that quickly. I can't, so I have no choice. Go p's, which are plus or minus 1 and plus or minus 2, plus or minus 3, and plus or minus 6. They just came from that. Then q's are going to come from here. It's going to be plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Holy cow. Alright, when I put 1 underneath all of these, I'm going to get plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. When I put 2 underneath all of this, I'm going to get plus or minus 1/2. 2 over 2 is 1, so I already have that. And plus or minus 3 over 2. And then plus or minus 6 over 2, which is 3, and I have that. Put 5 underneath all that, and we'll get plus or minus 1/5, plus or minus 2/5, and plus or minus 3/5, and plus or minus 6/5. Okay, and then when I put 10 underneath that, I'm going to get plus or minus 1/10. I get plus or minus 2/10, which is 1/5. I have that, and then plus or minus 3/10, and then plus or minus 6/10, which will be 2/5. Okay, I have that, so we're good. 1/5, 2/5. Okay. We have options 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times 2, 24 choices. 10, 21, -1, -6, and I got to get a 0. What should I pick? Guess? No guesses? Olivia? -2? Okay. I'm going to put trust in you. It will work, huh? Alright. 10. -2 is going to give me -20. 1. Multiply. -2. Add. -3. Multiply. Thank you, Olivia. Came through. -2 works. So x is equal to -2 is one of my factors. If Olivia didn't come through, I had to guess and check. Okay. So this is 10x squared plus x minus 3 is equal to 0. Okay, I'm trying to factor now. If I can factor that, okay, I can go 10 and 1. 10 and 1 might be too big for me. I think I'm going to go 5x and 2x. Gotta get a 3. Okay. And that ain't going to do it. Alright, so 3 here gives me 8, and 1 there gives me 2, so that's going to give me 1. So 3 here and 1 here will give me, yeah, that'll work. Alright, so 3 there, then we'll make that a positive and a minus. And that works. So therefore, when I set that equals 0, I get x is equal to -3 over 5. And set that equals 0, I'm going to get x is equal to 1 over 2. And there it is. I have 3. That's because I have power of 3. So if it's power of 4, I'm going to get 4 answers. Power of 5 gives me 5 answers. Alright? So that will tell you how many answers you should get. Alright, that's it for section 12. Okay, let's go to section 11. Okay, this is graphing. Yes, sir. Number 12. 11. Sir. 10. 10, 11, and 12. Graphing. Alright, let's look at 10. Okay. 10, I have a y is equal to cosine of x minus pi over 3. Okay, the amplitude, I'll write everything out for you right now, but you don't have to. Amplitude is 1 because that's 1 in the front. Okay, my frequency is 1, and because it's 1 right there. Okay, amplitude's there, frequency's there. Well, that means my period is going to be 2 pi divided by 1, which is still 2 pi. Okay, this is my horizontal shift. So my horizontal shift is, okay, pi thirds to the right. And at the end I should have a number, but I don't have it. I have a 0, so vertical shift is I have none. No vertical shift. So this is a cosine graph. Okay, so I'm going to draw a temporary y-axis because I know I have a horizontal shift. If I didn't have a horizontal shift, I would just go ahead and draw the permanent y-axis. But now I'm just going to move that in a little bit. So, alright. So let's call this 0. Amplitude is 1. Call that 1. Call this negative 1. Period is 2 pi. So 0 to 2 pi. Halfway between that is pi. Halfway between that is pi over 2. Halfway between that is 3 pi over 2. Okay, this is a cosine graph, positive cosine graph. That means it starts on the top, crosses the middle here, hits the bottom there, gets back to the middle, and goes back to the top. So that's my graph, except I haven't done anything with horizontal shift. This is pi units to the right, means I'm going to add pi thirds to everything. So 0 now becomes pi thirds. Okay, to save time, I'm just going to write plus pi thirds here. Plus pi thirds. Plus pi thirds. Plus pi thirds. Everything gets added pi thirds. Alright. But remember, this is our old y-axis. Y-axis doesn't go through pi thirds. Y-axis goes through 0. So you'll have to move that y-axis to the left of that and call that a 0. Call that 1. Okay, and obviously that's negative 1. And then you must erase the old y-axis, so there is no confusion. Okay, and then now we can just write y right there. Okay, that is a cosine graph that is shifted pi thirds to the right. Okay, alright, so that's 10. Let's go to 11. So number 11, you have y is equal to 1 plus cosine of x minus pi over 2. Okay, let me rewrite this in a little different fashion so I can explain it to you a little bit better. Okay, amplitude is still 1 because that's the number in the front. Okay, so amplitude is still 1 because that's the number there. Frequency is still 1. Okay, so frequency is 1, so that means my period is going to be 2 pi. Okay, and then this is my horizontal shift, so my horizontal shift is, okay, pi over 2 to the right. And this is my vertical shift, so vertical shift is 1 unit, 1 up. Okay, so I'm going to draw my x-axis. I'm going to draw my temporary y-axis because I know I have a horizontal shift. But I also have a vertical shift, so I'm going to go up here, call that 1, and then I'm going to draw my new middle using a dotted line. Okay, amplitude is 1, so I'm going to go up 1. That will be 2. Go down 1. That will be at 0. My period is 2 pi. Go over here, call that 2 pi. Start cutting everything in halves. Pi over, that's pi, and this would be pi over 2, and this would be 3 pi over 2. Okay, so I'm ready to graph everything except this. I'm going to take care of that at the end because it's just easy for me to do it that way. Okay, alright, so this is a positive cosine graph. Okay, it's going to start here, across the middle there, hit the bottom there, get back to the middle there, get back to the top. So cosine starts on the top, sine starts in the middle, and that's my cosine graph. And everything is taken care of except my horizontal shifts. I got to add pi halves to the right. So pi halves to the 0 is going to give me pi halves there. Okay, this is going to be pi over 2. Of course, when I add pi halves to pi halves, that turns into a pi. When I add pi halves to pi halves, I get pi. Pi halves to a pi, this is 3 pi halves. And then when I add pi halves to 3 pi halves, that turns into 2 pi. And then when I add pi halves to 2 pi, that turns into 5 pi halves. So last one is 5. Come on. Okay, I have a problem now. The problem is my y-axis. It's got to go through 0. Okay, so I'm going to move y-axis. It's going through 0. Okay, and this is my 2, and that's my 1, and that's my 0. Okay, put some arrows on that. Call it y, and make sure to raise the old y-axis. That's it. Alright, 12. Number 12. Okay, I have a y is equal to 2 minus 3 sine of 2x minus pi over 2. Alright, this is the hardest one because it has everything in it. Okay, I'm going to rewrite everything. Okay, I'm going to move the 2 to the end. I have a negative 3 sine. I'm going to factor out a 2 from here because I have to have an x. So when I factor out 2, I have to factor out 2 from all of that. So I'm going to get x minus pi over 4 in the parentheses. Okay, and then I have a plus 2 at the end. This is my amplitude, which is 3. Okay, not negative 3. Negative just tells me it just flips. The graph just flips. And this is my frequency. Okay, that means my period is 2 pi divided by 2, which is pi. And this is my horizontal shift. Okay, that means I'm going to go pi force to the right. Okay, and this is my vertical shift. And that means I'm going to go 2 up. Okay, let's graph. Temporary y-axis because I have a horizontal shift. I do have vertical shifts 2 units up. Go up here, call this 2. Okay, now let's get the amplitude. The amplitude is 3. I go up 3, which puts me at 5, and I go down 3, which puts me at negative 1. My period is pi, so 0 to pi. Call that pi over 2, call that pi over 4, and then call this one 3 pi over 4. I can graph it right now as is. Okay, I can move the axis in a second, but this is a negative sign. The sign normally starts in the middle. That's my middle. Okay, sign starts in the middle, goes up, but because negative sign starts in the middle, goes down. So it's going to start here. It's going to go down to here at pi fourths, and it's going to go back to the middle at pi halves. Okay, and then it's going to go up to 5 at 3 pi fourths, and it's going to go back and start. Go back to the middle again right there. So my curve looks like this. Only thing I need to take care of is I got to add pi halves to everything. So pi fourths. So 0 becomes pi fourths now. So I'm going to change that to pi fourths. pi fourths plus pi fourths is going to give me pi halves. So I'm going to change this to pi halves. And then pi halves becomes 3 pi fourths. And then 3 pi fourths just becomes a pi. And then pi, adding that pi fourths, that would be 5 pi fourths. Y-axis has to go through 0. So make new y-axis, call that 0, call this 2, call that 5, call that y, okay, and this is -1. So erase the old one, and then we're done. Alright, let's go to section 10. Alright, section 10. Yes. 3. Yes, 3. 5. 4. Yes, 6. Okay, 3. Okay, 3 is tangent squared x minus tan x is equal to 0. And we do have a domain restriction 0 to 2 pi, excluding 2 pi. Means there's parentheses on 2 pi. Factor it out. Tan x minus 1 is equal to 0. Okay. Set each factor equals 0. Tan x is equal to 0. Tan x minus 1 is equal to 0. I get tan x is equal to 1. Alright, where is tan x equal to 0 on the unit circle? Well, tan x is equal to 0 when sine is 0. Where is sine 0? Sine is 0 here and here. So I get x is equal to 0 and x is equal to pi. This is where is tan x equal to positive 1. Tan x is equal to positive 1 where sine and cosine are exactly the same. Where in the unit circle sine and cosine are exactly the same? It's right there, which is pi over 4, and which is down there, which is 5 pi over 4. Okay, so x is equal to pi over 4 and 5 pi over 4. And that's it. Okay, so 4. 4 says 2 cosine squared x minus cosine of x is equal to 1. Again, domain restriction 0 to 2 pi. Okay. It's a quadratic, that means I got to take everything to one side. And then I got to factor. Okay. When I factor, I'm going to have a 2 cosine x and a cosine x. Factors of 1 is just 1 and 1. And I need to turn this into a negative and that into a positive, and it's factored. After I factor, I set everything equal to 0. Here I'm going to get cosine x is equal to -1/2. Here I get cosine x is equal to 1. Okay, let's take care of this. On the unit circle, where is cosine equal to -1/2? Well, you got another unit circle inside out. It's right there. I don't want decimal answers. Okay, so -1/2 is right there, which is x is equal to 2 pi thirds. -1/2, cosine is also -1/2 here, which is x is equal to 4 pi thirds. Okay, where is cosine equal to 1? Cosine is equal to 1 here, which is 0. Also 2 pi, but we're excluding 2 pi because of the parentheses there. So that's it. Alright, 5. Cosine x plus sine x is equal to 1. Who asked for 5? Is that you, Sarah? Who? You did? You want me to do it the easy way or hard way? The shortcut, common sense way, or algebraic way? Both. Alright. I'll do it the common sense way. Common sense way is just know the unit circle. When you add sine and cosine, you gotta get 1. The only way that can happen is here. That's because that's 1 comma 0, right? Okay. Also here, that's because 0 comma 1. There's nowhere else where you add sine and cosine you're going to get positive 1. So that means your answer is x is equal to 0 and pi over 2. And that's done. Now the algebra way, here we go. Okay, I sit here, try to figure out how to solve it, can't do it. All else fails. Let's just square it, see what happens. Square both sides. When I square this, I got to expand that binomial. That is cosine squared x plus 2 sine x cosine x plus sine squared x is equal to 1. Then I notice sine squared plus cosine squared is a trig identity. That's 1. So I get 2 sine x cosine x plus 1 is equal to 1. Take the 1 over, you get 2 sine x cosine x is equal to 0. Divide by 2, you get sine x cosine x is equal to 0. Set each factor equal to 0. Sine x equal to 0. Cosine x is equal to 0. Okay, where is sine x equal to 0? Sine x equal to 0 here and here. So you get 0 and x is equal to pi. Where is cosine x is equal to 0? It's here and here. And you're going to get x is equal to pi over 2 and x is equal to 3 pi over 2. But remember, we only had 2 solutions. Here all of a sudden we're getting 4 solutions. Well, whenever you square things, remember all kinds of funny things happen. So you have to go back and check and see which ones really work. Okay? So you're going to put in 0 first. Okay? So when I put in 0, right here and here, okay, I'm going to get 1 plus 0, which works. But when I put in pi here and here, this becomes negative 1 plus 0, so pi does not work. And then when I put in pi halves, it will work. I get 1 again. I get 0 here and 1 for pi halves, and that works. And when I put 3 pi halves, okay, and I get 0 and negative 1, and that doesn't work, so eliminate that. Got that for you? Okay. Alright. That was number 5, so we're going to 6, I believe. Alright, 6. Sine x is equal to cosine x. Alright, how do you want to do it? Easy way? Okay. Alright. Easy way is simple. There's only 2 places where sine x and cosine x are exactly the same on a unit circle. It's here, which is x is equal to pi over 4. And it's here when x is equal to 5 pi over 4. Okay? Alright. Section, I hope you don't have any problem with section 9. It's just a unit circle. Okay? Only thing is, when you get 11 pi over 5, it's not part of the unit circle, is it? Punch in your calculator. Make sure you bring a scientific calculator with you. Fine, bring a graphing calculator. Now I want to see all the work from you. Alright, how about section 8? Section 8, yes sir. Number 3. Yep. 1. Alright, start with 1. If you know 1, you can do them all actually. So 3 comma 4. Okay, they say this is a point. Call this 3, call that 4, and there's your point 3 comma 4. And they want you to find this is in a standard position. Okay, so that means you're going to connect from the origin to that point and make a triangle on the x-axis here. Okay, so that's going to be your 3, that's going to be your 4. That means, what's my hypotenuse right now? Geometry. Thank you. If you don't know that, you can use Pythagorean theorem. Okay, that's my angle, theta, always. Now what we're going to do is we're going to write out all 6 trig functions. Sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. And then of course cosecant of theta is just going to be sine flipped. Okay, and secant of theta is cosine flipped. And then cotangent of theta is tangent flipped. That's it. Alright, number 3. Emma, you got a calculator with you? Alright. X is 8. Y is negative 15. There's my point. Connect. There's my angle theta. Draw a right triangle. X-axis. This is the 8. This is minus 15. Okay. How do I find my hypotenuse? Pythagorean theorem. So 8 squared plus negative 15 squared is equal to c squared. So this is 64 plus this is 225 is equal to c squared. And that's going to give me a 9, 8, and 2. And c squared, what's my c equal to? Square root of 289. Is that a perfect square? Huh? 17. 17. Once I have that, what's my sine of theta? Opposite, which is negative 15, over hypotenuse, which is 17. What's cosine of theta? Adjacent over hypotenuse. Tangent of theta is opposite over adjacent. Cosecant of theta is 17 over negative 15. Secant of theta is 17 over 8. And cotangent of theta is negative 8 over 15. Alright, that brings us to the next section, section 7. So, section 7, number 2. Yes, Olivia. 3. Okay, determine whether the given function even, odd, or either. Okay, so let me refresh your memory. If a function is like this, that's y is equal to x squared, that's an even function, because if it's symmetric to the y-axis, it's going to be even. If the function's like this, which is y is equal to x to the third, that's an odd function. Well, even function is when you put in a 2, you get a 4. When you put in a negative 2, you get a 4. So when you put in a negative x, a positive x, you get exactly the same thing on even functions. Odd functions, when you put in a 2, you get an 8. Negative 2 will give you negative 8. That means you get exact opposite. So, easy way to do it is this. Okay, this is number 2. Y is equal to cube root of x. All you're going to do is, to determine even or odd, is replace x with a negative x. If it turns out to be the same, it's even. If it turns out to be exact opposite, then it's odd. Okay, and it could be neither because it's not the same or exact opposite. So y is equal to third root of negative x. Just change all the x's to negative. You can pull out a negative, so y is equal to negative cube root of x. Is this same as that, or is that opposite of that? Opposite. That means this is odd. Okay, number 3. Okay, y is equal to x times 4 minus x squared. Okay, we're going to replace all the x's with the negative. So minus a negative x squared. Okay, clean it up. Y is equal to negative x, all that times 4. When you square the negative x, you're going to get an x squared. Okay, is this same as that? Is that exact opposite of that? Or is it neither? Huh? Okay. Alright, so let me ask you this question. If y is equal to x, what's opposite of that? Thank you. If y is equal to 4 minus x squared, what's opposite of that? Negative 4 minus x squared. Opposite just means you're going to put one negative in the front. So, do you have a negative in front of that original equation? Yeah, it's opposite. So it's odd. Yes. Odd. What's that? This is just odd or even or neither. That's all. We're talking about symmetry there. We're coming to that. That's symmetry. Okay. It'll show up on, this stuff shows up on calculus. So you'll see it again. Alright. How about section 6? Anything on section 6? Yes, number 2. Okay, section 6, number 2. Here we go. Number 2. You're given y is equal to x to the third. Oh, let's write it the other way. Let's write it as f of x. It will be easier for me to explain. Okay, f of x equal to x to the third, and g of x is equal to third root of x. Okay, before you find composite functions, check and see if you have any domain restrictions. Is there any number I cannot use right there? No. Only time I get problems with numbers I can't use is fractions, logarithms, and square roots. So I'm good to go. Is there any number I cannot use there? I can use positive, negative, and 0. So this is all reals, and this is all reals. No domain restrictions before we start. Okay. Now we're going to find f of g of x. That means we're going to take g, put it in f. That means this is going to go inside of that, which is going to be third root of x to the third, which is going to give me x. Is there any number you can't use there? Nope. So it's all reals. Now, go inside. You always have to check the inside one. Okay, inside one says all reals too, so that means we're good to go. Always have to check the inside function. So the domain is all reals. Go the other way. G of f of x. Okay, that means we're going to put that in there, which is going to give me third root of x to the third. Okay, that turns into x. There's no number I can't use for that one, but I always have to check the inside, x to the third, and that's all reals too, so all reals. No restrictions. So these are the inside functions. Whichever one ends up inside, that restriction has to go with it. Okay, that brings us to section 5. Section 5. Questions. Domain. I don't care about the range for right now, but domain. It's critical. Yes, Victoria. Number 2. Anything else besides number 2? Alright, section 5. Yes, sir. Number 6. 2. Okay. We have h of x is equal to square root of a 25 minus x squared. Folks, anytime you see a fraction, square root, a logarithm, you're going to have domain restrictions. This is a square root, you're going to have domain restrictions. Inside there, yes, sir. Number 4. Oh, number 2. It's a typo. Number 4. Number 2 is a typo. Okay. You wish I put number 2 on the midterm. Okay, this has to be positive. Okay? That means 25 minus x squared has to be greater than or equal to 0. How do I solve a quadratic or higher when it's an inequality? You can't just solve it like a regular equation. You have to do what? You have to do number line test. That means you got to factor 5 minus x, 5 plus x, greater than or equal to 0. Number line, 0 in the middle. 5 is one of the critical numbers. Negative 5 is the other critical number. Pick any value, easy to work with. 0. Put 0 here, makes it into positive. Put 0 there, makes it into positive. So this is positive. That'll be negative, and that'll be negative. We're looking for where it's positive. It's positive there. So that means x is greater than or equal to negative 5, less than or equal to 5, and that is my domain restriction right there. In interval notation, this will be brackets, negative 5 and positive 5. Okay. Number 6. 6 is just like number 4. So f of x is equal to square root of a 9 minus x squared. It's a square root, that means this has to be positive. Okay, if that's positive, 9 minus x squared has to be greater than or equal to 0. What we're going to do, factor and do number line test. Okay, and you have to show this work. Don't just write down the answer because you've seen this problem before. 3 minus x, 3 plus x, and my number line, I'm going to have a 0. I'm going to get 3. Okay, I'm going to have negative 3. Okay, if you just write down the answer, I'm not going to give you any points for that. Put in 0 here and 0 there, so that becomes positive, be negative and negative. So my x is greater than or equal to negative 3, less than or equal to 3. There it is. Interval notation will be brackets, negative 3, comma 3. Alright, now we're coming to easy stuff. Section 4. Yeah. Alright, section 4. Yes, sir. Number 6. 3. Olivia, Victoria. 4 and 7. 5. Huh? I thought this was an easy section. Two. F of x is equal to x squared minus 2x plus 2. F of negative 1. What does that mean? There you go. Plug -1 for the x. Simplify. I'm not even going to simplify that for you anymore. Okay. What does f of c mean? What? What does that mean? What does f of c mean? Plug in c. What does f of x plus delta x mean? Plug in x plus delta x. Done. Is that plus 2? For C, yeah. Okay, that's 2. So let's go to 3. 3. F of x equal to square root of x plus 3. What does f of -2 mean? We'll get rad 1, which is 1. And what does f of x squared mean? Plug in what? Done. And then f of x plus h means you're going to plug in x plus h plus 3. Done. The first one here. Oh, no. It's always 1. You only get, okay, this is always a confusion. Okay. Let's say you had x squared minus 1 is equal to 0. And you get x squared is equal to 1. And you get x is equal to square root of 1. You get plus or minus 1 here. That's only because the question they're asking is what number can I put in here and square it and get 1. Both plus or minus work. Here, I'm not asking what number can I put there to get, you know, same thing. So here's, I'm just saying what's square root of 1, which is 1. Square root of 4 is 2. Okay, so a different question here. Slightly different question. Okay, so 4, 5, 6, and 7. Let's go to 4. Piecewise functions. AP test has a lot of piecewise functions. They like piecewise functions. So I like piecewise functions. So you better love piecewise functions on the midterm. Okay, A. They want me to find f of -1. Now you got to pick. Which one do I choose for this one? Top one or the bottom one? This is telling you the domain restriction right there. F of -1. Which one do I pick? Top one. When x is less than 0, pick the top one. 2 times -1 plus 1, which is -2 plus 1, which is -1. B. Okay, f of 2. Which one do I use for that one? Bottom one. Because 2 is bigger than 0. So therefore, I get 4 plus 2, which is 6. C. F of -2. Which one do I use? Top one. That'll be -4 plus 1, which is -3. D. Okay. F of t squared plus 1. Which one do I use for this one? I gotta use both. Every place I see an x, I'm replacing that with what right now? T squared plus 1. So it'd be 2 times t squared plus 1. Okay, plus 1. When t squared plus 1 is less than 0. I have a 2 times t squared plus 1 plus 2. When t squared plus 1 is greater than or equal to 0. Alright. Number 5. f of x is equal to x squared minus x plus 1. Okay, they want me to find f of 2. I'm not even going to insult your intelligence on this one. That's A. Not even going to do that. F of x plus 2. What are they asking us to do when they find f of x plus 2? Plug in x plus 2 every place you see an x. You do not have to simplify. You can leave it right there. Now finally, C, they want you to find f of x plus h minus f of x all that over h. That means we're going to do that first. Plug in x plus h. So it'll be x plus h quantity squared minus x plus h plus 1. And then you have a minus. And then you're going to plug in f of x, which is x squared minus x plus 1. I had put parentheses because otherwise this negative doesn't go with everything. All that over h. You can leave it right there. This is actually a definition of a derivative in this particular problem. When you say limit as h goes to 0, f of x plus h minus f of x, all that over h. In this particular problem will turn out to be 2x minus 1. That's next year's problem. Okay, but we're setting you up for a derivative. But right now, we'll let you slide with that. Next year, you'll have to simplify that, okay, and then take a limit of that. Okay, 6. F of x is equal to 1 over x. I want you to find f of 0. Well, that is no solution. Okay, f of x plus delta x. That's my A, this is my B. That's going to be 1 over x plus delta x. C, f of x plus delta x minus f of x, all that over delta x. This, we found that, which is 1 over x plus delta x, minus f of x, which is 1 over x, all that over delta x. Done. Same thing, this is also a definition of a derivative. It's coming up, but we'll leave it right there. You don't have to go any further. Okay, number 7, f of x is equal to 1 over square root of a x minus 1. A, f of x minus f of 2, all that over x minus 2. Okay, what is f of x? All that over 1 over square root of x minus 1. What is f of 2? When you put in 2 right there, you're going to get 1 on the bottom. So it'll be 1 over 1, which is 1. All that over, okay, x minus 2. That's done. B, they want you to find f of x minus f of 1, all that over x minus 1. Okay, this works out pretty good when you put in x. That's 1 over square root of x minus 1. When you go to put in 1 right there, 1 minus 1 is going to give me a 0 on the bottom. Can't have that, so this is no solution. Right, section 3. Yes. 3 and 5. Yes. 10. Alright. 3. Section 3. You're given 7 over 8, 3 over 4, and then you're given 5 over 4, and negative 1 over 4. And these are 2 points. They want you to find the equation of a line. Okay, what 2 things do you need to find the equation of a line? Slope and a point. I have 2 points, so I'm good to go with points. I need to find slope. How do I find my slope? Holy cow. How about changing y over changing x? You're at 3/4, you go to negative 1/4. How many steps does it take to get there? Come on. Think of a number line. 0, 1, you're at 3/4. -1, -1/4. How much is that step right there? 1 down, right? -1. Yeah, because you're at positive 3/4, you're going to the left. You went from positive 3/4 to -1/4. You went down one step. Yeah, you did. Okay, this is in different fractions. I'm going to multiply the top and bottom by 2. So this is the same thing as 10/8. You're at 7/8, you go to 10/8. This time you went up. How much did you go up by? 3/8. So change in y over change in x. Flip it, you'll get -8/3. That's your slope. Okay, which point do you want me to use to find the equation of a line? Doesn't really matter to me. Okay, unless you want to go find B, then you're really in trouble. Then you got to do a lot of work. But it doesn't matter how ugly the point is. I can still write out the equation of a line. Y minus 3/4 is equal to -8/3 times x minus 7/8. I'm done. That is the equation of the line. Yes. Y is equal to negative what? Y is equal to negative, and then what? X plus 3/4. Where'd you get that? Y is equal to x plus b. You went and found the b. Did you go find the b? Oh, seems like a lot of work for me. I mean, if you want to go find the b, that's fine. But I hope it's right. I don't know. Okay, 5. We have -1, 2, and m is undefined. Undefined means, do you get a horizontal line or vertical line? Vertical line. Okay, vertical lines go through what axis? That means x is equal to -1 is the equation. Okay, 10. 2, 5, and perpendicular to the slope, perpendicular to x is equal to 4. Okay, x is equal to 4 is this line right here. If it's perpendicular, it's going to go through the y-axis. So what's the y value in this point? It's a horizontal line. If this is a vertical line, that means the perpendicular one is going to be horizontal. Got that, Kevin? Okay. Alright, how about section 2? This is the symmetry one. Section 2. Yes, Olivia. Number 6. 4. Okay, 4 and 6. Let's try 4. Check for the symmetry. And you have to check for every one of these. Okay, x-axis, y-axis, and the origin. It's similar to even odd functions. Similar. Not exactly the same. Okay, when you check for the symmetry, let's start with the y-axis. Y-axis means you turn all the x's into negative x's. If you do that, and then if it turns out to be the same, it's symmetrical to the y-axis. So you're going to get negative x, y, minus square root of a 4 minus x, negative x squared is equal to 0. Clean it up. Negative x, y, minus square root of a 4 minus x squared is equal to 0. Is this exactly the same as that? No. So, not y-axis. X-axis. In x-axis, we're going to turn the y into negatives. So we're going to turn y into negative y's. Okay? So you're going to get negative xy minus square root of a 4 minus x squared is equal to 0. Is this exactly same as that? No. It's not symmetrical. Now origin. Origin, you're going to turn x into negative x, and you're going to turn y into negatives, and then simplify and see if you get exactly the same. So negative x times negative y minus 4 minus negative x squared is equal to 0. Clean it up. Negative times negative is positive, so we're going to be positive xy minus square root of a 4 minus x squared is equal to 0. Is this exactly same as that? Yep. So it's symmetric to the origin. So for when you're checking for symmetry, y-axis you put in x, for x-axis you put in y. Okay, negatives. And then for origin you put in both. Okay. 6. Y is equal to x over x squared plus 1. Alright, y-axis. We're going to turn x's into negative x's. When you do that, you're going to get y is equal to negative x over negative x squared plus 1, which is negative x over x squared plus 1. Is that same as that right there? Nope. So that's gone. X-axis. Okay. I'm going to turn, that means I'm going to turn y's into negative y's. So negative y is equal to x over x squared plus 1. Is this same as that right there? Nope. Okay. Origin. Okay, turn all the x's into negatives, turn the y's into negatives, and then check. So negative y is equal to negative x over negative x squared plus 1. Okay, that means negative y is equal to negative x over x squared plus 1. And when I multiply both sides by negative, my negatives cancel. I get y is equal to x over x squared plus 1. Is this same as that? Yep. So it's symmetric to the origin. What? Nothing. Alright. Finally arrived, section 1. Anything in section 1? Yes, sir. Section 1, number 11. Alright. Yes. And what? 5. Okay. 5 and 11. Just in time. Okay, let's start with 5. 5, I have x is greater than 1 over x. Okay, I cannot multiply both sides by x. You can't do that. If I do that, I'm in trouble. The reason for it is, I don't know if x is positive or negative, and I don't have to flip the inequality or not. That means I'm going to subtract that. Then I'm going to find the common denominator, which is x, so I'm going to get x squared minus 1 over x greater than 0. I'm going to factor everything. X plus 1, x minus 1, all that over x is greater than 0. Now I'm checking to see where this is greater than 0. But these are critical numbers, so I got to do number line analysis. My critical numbers are, on the top, I get 1, I get -1, and then I have a 0. Those are all my critical numbers. Then I'm going to do, I got to do each interval. Pick a big negative number, -billion. Makes that into a negative, negative, and negative, which is negative. Pick -1/2. Okay, this -1/2 makes it into positive, negative, negative, 2 negatives, so it's positive. Put +1/2. This is positive, this is still negative, and this is positive. 1 negative makes that into negative. Big positive number, like a billion. Everything turns into positive, so it'll be positive. The question is, where is this thing greater than 0? It's greater than 0 there, and it's greater than 0 there. Okay, this is x is greater than 1. That's one of my solutions. Here, I got to be careful. X is greater than equal, greater than -1, okay, and less than 0. Because you can never include 0 because 0 is coming from the bottom, okay, and that's your solution. Number 11, last one. Number 11, I have x to the 4th minus x less than or equal to 0. Factor out everything. I get x to the 3rd minus 1 is less than or equal to 0. Uh-oh, I'm in trouble because I forgot how to factor difference of 2 cubes. Last time. This would be x minus 1. The trinomial is going to be that squared. The signs in the middle will always be opposite. Multiply them together, you get x. Last term squared is 1. This is always prime. Always. You get two critical numbers, 0 and 1. Pick any number. Let's say billion. Okay? Positive, positive, positive. So it'll be positive. And this would be negative, and that'll be positive. The question is, where is this thing negative? It's negative right there. That means x is greater than, okay, equal to 0, less than or equal to 1. Why do I put equal to? Because there's an equal sign right here. Alright. Yes, sir. Because prime, I get nothing from there. If I were to try to solve for that, I get imaginary values. Okay. Alright. You're pretty much done with pre-calculus.